Hi again. So this is going to be one of the small case studies I'm going to talk about. This is Spanish verbal inflection. This is work I did for my dissertation 5 years ago, I think. So it's not the most up-to-date thing ever, but it's still interesting. I think because it shows you some of a simple case study for a type of approach to analogical classification, which I think works quite well. So just to recap very quickly, again, we're doing analogical classification. We're trying to predict classes from the phonology. In this case, I'm just looking at phonology, no semantics. And I am using here a very simple neural network with only one skip layer and a hidden layer. So no deep learning. And just this is the simplest type of neural network you can get. The reason behind this was that at the time I was working on a desktop and I didn't have the computational power to do anything more fancy. With a fancier model, you probably will get better results, but that's yeah. So this was good enough for what I was doing and for graduating, I guess. Pretty much anything I do here, you could do with handwritten rules or OT or schemas. It doesn't matter. This is more of a proof of concept of what I was trying to show. Model evaluation is again on accuracy scores, on kappa scores, and one important point I didn't discuss in the first video is that we were doing tenfold cross-validation. The idea of cross-validation is that you want to test whether your model is actually learning stuff and not just remembering. So if I train a model on a dataset and then test that model on the same dataset, then it's unclear whether the model will perform equally well on items it hasn't been trained on. So what we usually do is that we split our data into training and testing set, and we fit the model multiple times so that we train and predict all of the data. So tenfold cross-validation is called that because we do it 10 times. So we leave 10% of the data out of the training, train on the remaining 90%, we make the predictions, and then repeat 10 times. In simpler cases, it's possible to find analogical relations by hand. In these cases, I was using machine learning, so neural network, as I mentioned, because it's easier. There is no theoretical reason, there is no claim that this type of machine learning somehow represents what speakers actually do in their brains, or that neural networks have anything to do with the actual knowledge of speakers or processing or anything like that. It's just a simple automated way of inducing rules and patterns. They have the advantage that they can handle very large data sets. It's easier to train neural networks on tens of thousands of items with hundreds of predictors. They operate consistently. If I train a model 10 times, I know I'm getting the same model 10 times. If I try to find analogies by hand 10 times, there is absolutely no guarantee that I am going to be doing the same thing all those 10 times. I'm not just finding new analogies or new patterns or missing stuff. And it can detect patterns which can be very difficult for humans to see because it can explore complicated interactions. The main disadvantage of this approach is, however, that we do not see what the neural network is doing. It's very difficult to visualize what the patterns are and to fully understand what the relations in the data are. For that you need some manual work, and it's not possible to automate or to do easily. But that doesn't matter much, because the main questions of the study were not what are the patterns, but rather what's the predictability of the system. This is an old topic, Spanish verb inflection and non-stem alternations. It's been done many times before. I think it's an interesting topic nonetheless because it has some interesting difficulty, and it has had many different takes over the years. So it's always useful to test new models on old data for which we already have some results and see whether the old models tell us new things about the data. This is going to be a very quick, speedy introduction into the Spanish verb inflection system. It's similar to French, I think, with slightly different markers. So very quickly, there are three main inflection classes in Spanish, and they have to do, they are usually called thematic vowels, which are A, E, and I. You can see examples of three verbs for each of the thematic vowels: cantar, correr, and aburrir. And as you can see, they have different markers. For R, the markers are quite different. For those markers of A and E, the markers of A and E, however, look somewhat similar. There are some points of difference, some cells, but some are identical. For R, less so, only the first person singular. Well, from these cells, other cells do kind of share all the markers. In addition to these three main inflection classes, there are a multitude of different stem alternation patterns. Here are some of them. There are more. This is not an exhaustive list, and this might not even be the best way of abstracting the actual alternation patterns we find in Spanish. However, this is a useful way of summarizing this data for this particular data set, because there are many small patterns which have too few items to analyze properly, or it becomes very difficult to analyze once if only a couple of verbs have the pattern. So this is just an abstraction, so you can keep it in mind. And what you see is that we have consonant alternations. For example, B goes to T. The verb escribir goes to escrito in the participle. However, is fully irregular in the first singular and the gerund. Sometimes E goes to I, like in elegir, goes to elijo in the first singular. However, the participle and the gerund are as expected. Sometimes two cells can be irregular. For example, E goes to ye. This is a typical diptonization case with controvertir, controvierto, but it also does this weird thing where it goes to I, controvirtiendo. So these are actually two different patterns which come together, which we are abstracting as just one pattern. There is this N to G in componer, compongo. There is this IG pattern in contraer, contraigo. There is I to Y and adquirir, adquiero. I to J in fluir, fluyo. O to W, aprobar, apruebo. U to W, jugar, juego. S to sk, humedecer, humedezco. And this to yet, or this yet pattern for abrir, abierto. By the way, the pronunciation doesn't match the IPA because I speak Colombian Spanish, so it's slightly different from Spain's pronunciation. If you count all the patterns, there are over 100 different conjugation patterns, but we can't do that. We have to focus on the most common ones. Now, as I mentioned, Spanish verb inflection is a relatively old topic. Many people have worked on it, and a common pattern about most papers on Spanish verb inflection is that people have claimed that it is unpredictable. So, for example, Harris says that as has long been recognized, segmental phonological and morphological conditions do not suffice to predict the occurrence or non-occurrence of dictonalization. Or Albright, the choice of dictonalization versus racing is not predictable. Or Roca, conjugation class membership is unpredictable. So this is received knowledge, I guess, and what people mostly think about this kind of stuff. So I am looking at the database with 3,000 verbs. For the models, I reduced this to 910. And this is the distribution of the patterns across the database. You can see that most patterns occur with all three thematic vowels. However, some patterns only occur with ir, some only occur with er, that is IG pattern. And I only found one case of one pattern of one verb, which is ut-web, occurring with ar. But so it's unclear whether this is really the case for all the verbs or this is really an exception. One important point here is that these smaller patterns are independent from the thematic vowel. And that means they are a different dimension of inflection to that of the thematic vowel. The thematic vowel determines the suffix and markers, while these patterns determine what happens to the stem internally. This can be modeled as a case of cross-classification and inheritance hierarchy. If you're into that, that's not going to be the topic of this study right now. The models I am looking at are three. As I mentioned, I reduced the number of R verbs to only the 300 most frequent ones, because otherwise the data is very unbalanced and it's very hard for the model to predict the low frequency patterns. So this way we have roughly the same number of R, L, and IR verbs. And I am fitting three models, one predicting stem alternation, one predicting thematic vowel, and one predicting all both things together, so the full inflection class. And these three models work from the final three segments of the stem. So I extracted the stem and then predicted this. And then predicted this these three outcomes from the final three segments. The stem I defined as the here it's good, as the infinitive minus the thematic vowel and the final R. You could claim that this is a little bit questionable, because there is some additional information there which should be a marker, but that's usually how Spanish is analyzed. But you could do it differently. This is just a possible approach. You could define stem a little bit differently. In any case, so we're predicting inflection class from the final three segments of the stem. So what are the results? For stem alternations, you can see the results here. This is the confusion matrix. And basically what we see in this case is that we can predict stem alternation fairly well. Some cases we predict perfectly, like this BT alternation. Some cases or the IG alternation. Some cases we predict very well, like the G alternation or the J alternation. Some cases we predict okay, but not perfectly, like the O2E or the S2K, and most are regular. And for example, the A to Y, we more or less predict, and it's rarely confused with any of the other patterns, but some could wrongly predict it as being regular. Same with A to E. This is somewhat expected, and but it's very interesting. The point is that some of these patterns are fully predictable and easy to see how they are predictable. For example, this IG class are all verbs which have a stem which ends in A. Things like caer, that the stem pica, and that ends in A, and it's caigo. So that's a very good predictor. For the G class, it's mostly stems which end in N, like tener tengo, and derives from tener. On the other hand, for things like the diphthongization, the patterns are less clear, and two identical stems can have either diphthongization or not. Here's an example of two verbs which have the same stem but belong to two different main inflection classes, podar and poder. And as you can see, podar does not have diphthongization, while poder does. So the point in this case is that predictability is not either predictable or unpredictable, but rather gradient. Some of these patterns are fully predictable and others less so. And there is a gradient between the most predictable and the least predictable. But crucially, there is no pattern which is not predictable at all. Some are difficult, but still to some degree predictable. Here are the accuracy values of this case study. You see that the accuracy is actually pretty good. The no information is rate is relatively high, but the accuracy is still quite above that, and the kappa score is also very good. So our model is overall predicting inflection class very well, at least for these patterns. Now, we can do essentially the same thing for thematic vowels, and in this case we get slightly worse results. It is relatively difficult to distinguish R from I, and they get a little bit confused, but still the accuracy is very high, and it's quite far away from the no information rate, and the kappa score is very good. Finally, this is the confusion matrix for the full inflection class. Here I am not giving you the actual numbers, but rather a heap map. And I am doing this because the actual numbers are relatively difficult to read in a table this big and kind of meaningless. The heap map works as follows: the more the blacker the box, the higher the number in there. And you can see here that most of the predictions are on the diagonal, meaning that the predictions are correct. There is some confusion, and the confusion is mostly on the R regular and the L regular. This is somewhat to be expected. These are the most common classes, and the most common classes will attract the errors of the model. So if the model is uncertain about an item and it doesn't really know what to do with it, it will assign it to one of the most common classes. This is a good strategy in general, because if you predict the most common classes, you maximize accuracy, and models try to maximize accuracy. So this sort of works. Right, so here's the accuracy and the no information rate and kappa. Again, the model is doing quite a good job. Inflection class is predictable. It's not perfectly predictable, but it's highly predictable. Another interesting point to look at is the overall similarity across the classes. This is a way of representing similarity in a 2D plane. So I calculated similarity between all the classes. I did this in terms of how much confusion was there between the classes. And what you see here is that the more similar classes will be closer together in the plane. And what you see here is that classes which share some degree of exponents are close in the plane. Interesting is that the G class is close in the plane to the IG class, for example. These two diphthongizations from O to we in R and R are very close. By the way, the coloring is done using here clustering, while the plane is done using multidimensional scaling. Right, so here is A to E and A to Y for ir and ar. And here are some other diptonization patterns. So this is, I think, interesting. More similar classes to cluster together. Again, so the analogical classification is clearly happening here. Now, you could also ask, well, the model works well, but this is just well, the data in raw. Are speakers really doing something like this when they learn Spanish? Well, I didn't do any studies, but luckily Albright, Andrade, and Hayes did, and they basically tested speakers of Spanish with made-up words, something like a work test. They presented the speakers with the conjugated fake verb in the third person plural, which doesn't show any alternations, and then they asked the speakers to conjugate the verb in the first singular. So, for example, with derrar, they presented the form derramos, and they wanted to see whether speakers would produce yo dierro or yo lerro, and there was some context. And then they made some predictions, and we can compare the degree of diptonization that the speakers did against what the model actually predicts, and the result is basically that our model has a correlation of about 0.6 with what the speakers actually did, and you can see it here. So this is the actually produced probabilities by the speakers. So how often did speakers use the diptonization, and the predicted probabilities by the model. You see that it's quite close. A few of the items like end and botr and nor and gimbal are somewhat far away from the predictions of the model, but not too far away. What this shows is basically the model is doing something similar to what speakers are actually doing. It's not perfect by any means. There is some information which is missed by the model, but it's more or less following speakers' intuitions. Now, the conclusions of this case study: Spanish inflection classes are partially predictable from the stem. Fully regular relations like the IG and BT classes are just a special case of analogical relations, and the model is actually very close to what speakers do. And that's it for this case study.